Hello everyone, good evening. How are you all doing? I hope everyone is doing super awesome. Okay, so exam days are almost close and I hope you all are doing so hard and so smartly also, right? Because working hard will not get you to the top, you have to be smart enough also. So that will make a huge difference in your mark and the ranks, right? Okay, so those who don't know me, myself Ameer Sir, Master Teacher of JEE Physics at Vedantu. You can call me Ameer for anything and everything, but only for physics, right? Okay, so here we are with another session of MCQ series, and what we have to discuss in today's class so that you get full marks in your objective questions in the board exam which is coming, we are going to discuss about the topic semiconductors, right? For some of you it will be a tough chapter, for some of you it is an easy chapter, so let's make it easy for each and every one after the session, right? Okay, so I hope everyone is ready for it. Before starting with the session, I just want to tell you one thing, that if you are facing any difficulty in any of the theory, okay, which means any particular chapter, let me say it is wave optics, or let me say it is ray optics or AC, wherever you are feeling difficulty, come to Vedantu site and buy your micro courses which mean that particular chapter. And how much you have to pay for it? How much can you think the least? It is 9 rupees. Just you have to pay 9 rupees for this course. I hope everyone can pay, which is lesser than Dairy Milk chocolate, right? Okay, so to make your life so awesome, so let's not waste our time, talk less and learn more is our motto. So here is our first question from the semiconductor chapter. What is it? An N-type semiconductor is it negatively charged, positively charged, neutral, and none of this? For every one of you, there will be having a tendency to go for negatively charged, but it's wrong. Okay, what is the actual answer? Neutral. Why it is neutral? How are you getting an N-type semiconductor? To the silicon semiconductor, which is an intrinsic semiconductor, you are adding a pentavalent impurity. Let it be nitrogen or phosphorus, right? So it was a silicon atom. If I draw, I think you will understand it best, right? Okay, so think that this is a silicon material, silicon atoms are there. To this you are adding a pentavalent, right? Let me say I'm adding some nitrogen or phosphorus, so any kind of metal which is pentavalent I'm adding, which will make this as an N-type semiconductor, right? Okay, so 4 of this nitrogen will be forming the bond, 1 extra electron will be there, that's all. But for cancelling that extra electronic charge, there is enough positive charge with the nucleus of the nitrogen, right? If you add 2 atoms which are neutral, how can the formed new material, which is N-type semiconductor, can be a charged one? Not at all, right? As both are neutral, the entire thing is going to be neutral. So an N-type semiconductor is a neutral object or a material, right? Very good. I know that all my students can understand just like that. In the half wave rectifier circuit, which one of the following waveform is true? So I hope everyone knows what is a half wave rectifier. What do you mean by rectifier? Conversion of AC to DC is called as a rectifier. So here only half of the waves is being rectified. Let's see what it is. Think that you are having the input as such. Let me draw the figure. So think that this is the input AC, okay? So this AC, which is having the waves in both the direction, has to be rectified so that it will be converted into a DC, right? So in the half wave rectifier, here what happens is, when it is passed through this particular diode, you can see that when the positive cycle comes, this end will be positive, this end will be negative, right? Yes or no? This is positive cycle, so this will be forward bias, so you will get the output from here. Okay, so in the output you will get the output cycle. Now think that when the input is having the reverse one, which means the negative part, so what will happen over here? What will happen here? It will be negative, here it will be positive. What is the diode, or how it is being biased now? It is reverse biased. In the reverse bias condition, will there be a current flow through the diode? Not at all. So in the negative half of the cycle, you won't be getting any output. So only in the positive cycle you will be getting output. So this is called as what? Half wave rectifiers. So which one will be the output? So the B part, or the B option, corresponds to our output, right? So we have the answer as B. Clicked, you got the answer and you got the marks in the board exam. Very good. Next, a 220 volt AC supply. Okay, when I talk about 220 volt AC supply, it is the average value, okay, or the RMS value. So how will you get the maximum value from the RMS value? I hope everyone knows that. Okay, what is the maximum value of an potential difference which is having an RMS value as 220? It is equal to 220 root 2 from the chapter AC, right? Okay, so the voltage given as 220 root 2, which is the maximum, it is passed through this diode and it is getting dropped across this. Means what? It is the capacitor. So the potential difference across the capacitor will be the maximum value of voltage given by the AC, which is equal to 220 root 2. So which one is our option for this question? Option D, right? Okay. In absolute zero, silicon act as. Absolute zero means it is a temperature of 0 Kelvin, which means temperature, heat energy itself is not there, and the silicon, which is just as a metal, will be acting as an intrinsic semiconductor. And in the case of intrinsic semiconductors, how free electrons are being produced? Because of the absorption of heat energy or because of increase of temperature, right? Okay, so if there are no temperature of the heat energy is 0, or how many free electrons will be produced in that silicon conductor? How many? 0, right? So if there are no free electrons in the material, what kind of thing you will be having? Or silicon will be acting as what? If 0 free electrons are there, it will be acting as an insulator because current cannot pass through because of the lack of free electrons. Yes, it was a nice question, I hope, because it includes maximum theory. Next, the probability of electrons to be found in the conduction band of a intrinsic semiconductor of finite temperature, it depends on what? Okay, what will happen to the number of electrons in the conduction band according to the energy band gap and also regarding the temperature. So let me draw the figure of that. What figure are we talking about? The figure which writes the valence band and the conduction band, okay, and the energy difference between them is called as forbidden energy gap or the energy band, right? Okay, so if the electrons reaches the conduction band, the free electrons will be produced. That's what we have studied. Okay, how the electrons reach or from where it has to reach? The electron which is present in the valence band has to jump and reach the conduction band. How will it reach? If it gets this much of energy, which is equivalent to energy gap or the forbidden energy gap, right? Okay, so if the energy gap increases, what will happen? Will the number of electrons in the conduction band increases or decreases? It decreases, right? Because more amount of energy will be required in the increased forbidden energy band gap for the electrons to reach there, right? If more energy is required, less number of electrons will be reaching the conduction band. Yes, okay, so it decreases exponentially, which means the number of electrons in the conduction band decreases exponentially with increasing band gap, which means if the band gap is increased, it will be more difficult for the electrons to move from valence band to conduction band. Why? Because it will require more amount of energy. Great, it was a good question again, if I can tell. If a small amount of antimony is which group element? 15th group element, which means it can act as a pentavalent impurity, right? Which can have 5 valence electron, where extra one electron will be acting as what? The free electrons, right? Okay, is added to germanium crystal. So if pentavalent is added to a germanium or a semiconductor crystal, it will be acting as an N-type extrinsic semiconductor, right? Okay, so what will happen? Its conductivity will increase because of the number of increase of electrons which will be acting as a charge carrier, right? So which option? There will be more free electrons than holes, right? Because it's a pentavalent impurity. Okay, each antimony atom will be giving 1 extra electron, which will increase the number of free electrons than holes in the semiconductor. Yes, good. Okay, where is our next? Barrier potential developed in a junction diode opposes the flow of what kind of current? So let's see what is this barrier potential, right? Okay, so here we have a semiconductor which is PN. Okay, along the junction, when the junction is formed, what will be happening? The majority charge carriers will flow across the junction. Okay, what is major over here? Electrons. So electrons will go to P and the holes will be moving to N. If electrons leave its atom, what will be the charge attained by the atom? Positive, right? So on the N part, you will have positive immobile atoms. Similarly, if holes, which is almost considered as a positive charge, leaves, here you will have negative immobile atoms. And what will this resist? This positive charge over here will resist the further flow of holes to the N part, right? So the flow of holes to the N part is actually the flow of majority charge carriers. So the barrier potential opposes the flow of majority carriers only across the junction. So where is our option? We have the option B as the answer, right? Good. Next. The circuit has two oppositely connected ideal diodes in parallel. I hope you can see it, right? Okay, so 2 ohm, 3 ohm, the diode is like this and this diode is in this fashion. Okay, 1 minute. So this diode is in this fashion. I hope everyone can see that, right? And this diode is in this fashion. Okay, now they are asking the current. So let's start. So here is a potential difference. The current will start flowing through this resistor. From here it will diverge, okay, because two circuits are there. Some current will be passing through here. Will a current be passing through the second circuit or the second loop? Will it be passing? Not at all, because in the second loop, this diode, what you can see, is reverse bias because of the potential difference which we are giving externally. So the current will not be passing through because the reverse biasing resistance of the diode is very much higher, so the current can almost be equivalent to 0. So this is the only active circuit of ours. Okay, so in this active circuit, if you don't consider the resistance or the voltage drop across this particular diode, I will be equal to V, which is 12, divided by R is 4 and 3 is connected in series. So 4 plus 3, total resistance is 7. 12 by 7, you will be getting almost the answer as 1.73 ampere. So which one? Which option we can go for? We can go for the option C, right? Very good. My kids are becoming so super good. Next, the frequency of output voltage waveform is n times and the frequency of input voltage waveform of full wave converter, the value of n is. Again, once again, the frequency of output voltage waveform is n times the frequency of input voltage. Okay, so what I am going to write it, let us write whatever it is given in the question. What is given in the question? Voltage of the frequency, sorry, not voltage, the frequency of, let me draw this, frequency of output voltage, frequency of the output is equal to n times the frequency of input. Okay, in the case of full wave rectifier. So again, like I told you, what is rectification? Conversion of AC to DC. Here the entire wave is being rectified. Let's see the input wave and the output wave, right? Okay, so how will the input wave be? It is an AC which we give, right? Okay, so in the full wave rectification, not only the positive half is being rectified, the negative half is also being rectified, right? So how many number of waves are here? 1, right? Okay, so the number of waves in the first case is only 1. How many waves are over here? Here it is not one wave. Look, one wave is here and it is repeated again, which is, this is another wave. So 2 waves are there over here, right? So frequency of the output will always be equal to 2 times the frequency of input, right? Which means, how will you write 2? This frequency of the output 2 is equal to 2 times of frequency of the input, which is 1, right? So n corresponds to a value of how much? N corresponds to a value of how much? 2, right? So don't you think it was simple? Guys, you have understood or not? Tell me yes or no. Where is our closing button? Yes. So I think that this chapter you might have understood in a better way, and now you are able to solve most of the objective level question. That is more than enough. That was my actual intention also with this particular class or the session, right? So if you still are facing some difficulty in the theoretical question or in the theory or in the previous year question, you can come and watch all my videos which I have done regarding the theory and my previous year questions. Okay, so you can type my name and the topic name, you will be getting that. It will help you a lot, which means we are doing the previous year question. It is a great thing. So guys, I think you have liked my class, you have grabbed some knowledge. Then what is preventing you from hitting the like button over here? Okay, so please hit the like button, and if you think that your friends are also going to get benefited from this particular thing, please share this video with your friends and ask them to come and join my class every day at 6:30. Then what is it? The last part, the button which is going to get benefited for both of us, right? Like I used to tell every time, if you hit the subscribe button, I'll get to know that you are understanding. Okay, it will give a motivation for me to do more and more number of videos, right? It will also make me happy as a teacher. So don't forget to do that. And what is the part or what is the benefit for you? You will get the notification from the Vedantu channel in YouTube all the time whenever we upload new videos, so you can watch it at the right moment and you can get a lot much of knowledge where you can apply it in the papers, answer sheets, and you get a lot much of marks in your board exam and in the JEE. Right? So don't forget, you have to take only 2 seconds, move the cursor and press the subscribe button. It will do a lot of help for a lot many people, right? Okay, so thank you so much for watching and listening to my class. Okay, so till we meet next time, bye bye guys and take care.